Good afternoon, good morning, wherever you are. Welcome to today's webinar, Data Centers at Crossroads, Energy Cooling Policy Challenges. My name is Suir Hamemi. I have the pleasure today of moderating this session on behalf of the International Institute of Refrigeration. The IIR is a leading intergovernmental organization dedicated to refrigeration, heat pumps, and cooling technologies sciences. Founded in 1908 and headquartered in Paris, we bring together over 60 member countries and global network of leading refrigeration scientists and experts. Our mission is to compile and share knowledge on refrigeration and cooling technologies, connecting research, industry, and policy to drive informed decision making worldwide. Today's event is an initiative between IIR and ASEAN Centre of Energy, ACE, the regional intergovernmental body mandated to support ASEAN member states in achieving sustainable and secure energy systems. Together, we're bringing technical rigor and regional policy relevance to one of the most pressing infrastructure challenges of our time. Data centers are expanding rapidly across Southeast Asia, and with them, the energy and cooling demands that will shape the region decarbonization trajectory for decades to come. This webinar, we're bringing together experts from across policy, engineering, and energy modeling to examine this challenge and explore pathways forward. A few practical tips of today. We will be recording the video for it will be available after the event online, and please use the chat box for questions if you do have any questions. And I will be honored today to have three experts of the matter. I will be joining. I will be together today with Yudiandra Yuono from ASEAN Centre for Energy, Ana Laura Ransadeli from Danfoss Climate Solutions, Prof. Shuang Guan Shao from Huanzhong University of Science and Technology. What we will be speaking today about, the first presentation, we will have Mr. Yudiandra Yuono, Senior Energy Modeler at the ASEAN Centre for Energy, will be presenting on anticipating uncertainty in data center, electricity demand, examining how IT infrastructure is reshaping the energy planning across ASEAN and what means for regional policymakers and system operators. Second, Ms. Ana Laura Ransadali will present the EU policy experience, examining the drivers and performance indicators that are shaping sustainable data center development in Europe and what lessons may travel to other regions of the world. Third, we will move to Professor Shao from Huanzhong University. Will take us through the engineering part of the equation, presenting the state of art and sustainable cooling technologies for data centers. And finally, the fourth part will be a Q&A session to welcome your questions to the three esteemed speakers and to discuss together throughout the session. So we move to the first speaker for our presentation, and to Yundiandra. Over to you, the floor.
Thank you. Thank you, Sohir, and greetings all attendees. So my name is Yudiandra from the ASEAN Centre for Energy, and yeah, opening the sessions today with this topic about the uncertainties that comes with all the demand surge from data centers, and I think also then get even more amplified with the versions of AI data centers that also comes in the bulks of demand for all the ASEAN member states. So yeah, we're from ACE. I'm from the ASEAN Centre for Energy. So ASEAN Centre for Energy is the intergovernmental organization, or basically the think tank for energy that serves all the ASEAN member states, all 11 of it. And yeah, our role as the think tank of the ASEAN region is to advance the energy goals that we have in several written and pledge, and also collaborative targets. Also to function as the data and knowledge hub for the entire region, and also to serve any kind of needs for research and practical solutions. So we serve all the 11 member states as collectively and also individually. So this topic, it was something that has been raised to us from developing partners, from international organizations that work with us, and also from the member states. And some key highlights of the discussions that I'll bring today is there's the three key levers that now controlling the entire data center demand in ASEAN. And the future electricity use is very tied closely to this, and is controlled by the hardware power density, air penetrations, and utilizations, and the PUE. And also one of the key things that we find from the discussions with the member states and also some consultations, the facility type is also something that will control the narratives and also how it is physically will appears in the region. And after that, we're getting into the imperative of some policy responses from the member states, which we'll get to that later. And yeah, and one of the highlights then also that we, as a region, has an opportunity to avoid some mistakes to collectively assess the issues moving forward. And so it starts from the fact that the digitalizations is starting to take its shape in the region. So as a jargon, it's been around for a couple of years, but then it starts to appear more holistically and also more tangibly throughout the regions. The traditional drivers from the usual demand growth that comes to the energy sectors from population, economic expansion, urbanizations is still the core in the region. However, the digitalizations, digital economy, and also all the drivers that comes with that, cloud services, internet use, and that comes with the advancement of technologies also trying to takes its shape. And again, as per usual, the government is always a few steps behind in responding to all the changes that comes, despite there's actual learning from other regions. And this is also what's different with the data centers and AI, because I think us globally is also playing catch up with how it turns to us and all the challenges and how it actually materialized. And this is that we're facing now. So from the jargons, from the uh, demands that comes in paper, now it starts to takes its shape physically. So it's starting to materialize, and all the consequences that comes with that is also starting to take shape. And there's demand uncertainties that comes with all the requests to the member states, all the constructions, all the contract that comes for building new data centers. And there's a numbers that comes from the consultations with member states. There's announced pipeline, and it is higher than the realized load. And all the things that comes, I think we calculate that it comes faster than how the actual builds physically that it comes. And the constraint of all that, from the technical perspective and also from not only from the energy perspective, it is something that we shared globally. So all the labors, all the contractors, the chips, the copper that we need for all that, it is something that's shared globally. And issues that comes also that the member states now starting to realize is that all the projections now that it is past USD 400 billion in 2025, it, it is potentially will be completed faster than how the grid itself, the power capacity itself in the member states is being developed, because the two things comes differently. Some member states now already taking some build contracts that might then extend their demand load even faster and even more than the supply that they have. And the other things that also some of member states have been consulting with us is how far and how much that this will be going throughout the future, because they're thinking about capitalizing the possibilities of this, but also at the same time, they don't want to overcome it with the potentials that comes. And another key issues is, despite the region, as written here, have the ASEAN Plan of Action for Energy Corporations that aim for more renewable energy in the region, that all the demand that comes is then now forming as an additive for the fossil grid, because the fastest way to catch up with the new load that comes is just to build new fossil on top of the current fossil heavy system. It is also acknowledged on the APEC document that the digital economy is part of the rapid growth, and it is not clearly been addressed as fast as that with the member states and also all the stakeholders involved. And at the end, the grid cost allocations is something that will be bared by the entire system, not only with the new demands that comes from the data centers and AI infrastructure. The new realizations that comes is also how different some of the new demand is from the AI facilities because it comes in a different load class. I think we'll be getting into more technical later, but this is something that already appear and shown itself in the ASEAN region. So not only that it demands more from the technical perspective, but it also then comes with issues with the region itself. The tropical cooling adds more megawatt for each infrastructure. And at the same time, the new AI data centers comes with sharp swings load profile that it doesn't fit well with the biggest potentials of renewable energy in the region that comes from solar PV. And the question is now whether we add more load and we add more storage to that, then it will then at the end add more costs that will be again bared by the entire system, not only with the new demands. And here's just some look on all the registered and upcoming projects in the region. The analysis that we're currently doing that will be fully published in a couple of weeks, and also in the ASEAN Energy Outlook 9 that will comes later this year. There's a clustering for all this demand that comes from data centers, and it is logically stick around where the civilization is. So they shared this with the big cities throughout the region. With Singapore, Johor, Kuala Lumpur corridor now is one of the most extensive growth for all of this infrastructure. And currently it's around 5 gigawatt only for the power capacity for ASEAN. I think for an illustration, Malaysia, I think now have around like 25 gigawatt capacity. So it takes a lot of demand from the power sectors and some projections that comes from the member states with how much of the backlog, how much of the requests and potential contracts that comes to them. We've seen around up to almost bigger than 50 gigawatt additional power capacity in the next 5 to 7 years. And that is massive. That could double Malaysia power generation by itself. And yeah, it is shared throughout the entire regions, but it is also then densely concentrated around some parts of the region. So it is not really sparse. So I think one of the key things that we do throughout the few weeks and then what we'll publish soon is that we, along with the member states, is try to do some growth projections. And one of the key disclaimer when we're trying to do this with the member states that the unreliability of such projection, especially for long term, because we've seen a demand that shots up from almost zero to then suddenly 50 gigawatts or some even 80 gigawatts in some projections. And that comes from real demand, that comes from real constructed to be, that can be constructed within months. So when we do this, the only things that will slow itself down is just how fast the member states can play catch up with how much energy that they can provide, how fast they can procure the lands. And we all know that when it comes with money, then usually it can comes fast along. But then the risk that comes with all that, how the cost will be borne, how the other consequences will be seen is something that we need to, catch up very soon with this. So Malaysia now faces one of the most acute demand concentrations with how it grows within the countries. It can grow very high to almost taking 50% of their total load. And possible steep is really coming in the next few months because some of the projects is already almost being agreed throughout all the member states. So we might be seeing an issues that's already faced in Europe, already faced in the States, how then it will materialize itself in the region. And some member states, that comes with less strict policies, that comes with, I think, it's not that there no demand there, but the data is less well tracked compared to some of the advanced member states. Then we might suddenly see some potential jumps that comes out of nowhere just because we don't know, just because the country itself has no way to track this demand shots. And yeah, So the entire region is share some similar uncertainties. We don't know how it will grow. We don't know how fast it will grow. We don't know how fast it will takes the makes a competition between other demands. And the only things that we can tell that we can prepare ourselves is just how then we can stay prepared and how we can just try to be a bit ahead of the consequences that might comes. And we did discussions with the member states to try to be more prepared in facing all this, be more, trying to grasp and control with the uncertain situations. And we conduct some regional knowledge sharing, things that will come, I think, more often and more intense in the coming months. Some member states are trying to lead the process, trying to standardize the process of how this is happening throughout the regions. Because Singapore and Malaysia, for example, are now trying to implement structured measures to address data centers' energy implications because we start from energy, but then we'll see more implications in other sectors and trying to make some knowledge sharing within the member states. And the region is also trying to enhance itself with better reporting frameworks and demand visibility because not all, again, as I previously mentioned, not all is even now being able to identify this growing demand within their own countries. So the government in some places are way behind on the realities on how it already grows nationally and also regionally. And then so the frameworks is now being shared, try to find ways to provide some infrastructure so that everyone can catch up with that. Because as we all might know, the ASEAN Power Grid is something that is active and being developed and also in the coming months. So the demand that comes from individual member states is also something that will be uh, the consequences will be faced by other member states, especially concerning RE. We have some limited baseload that only comes from certain member states, and the potentials is also not something that is so abundant because of the difference of how the load and supply have its curve itself. So we also prioritize efficiency focused measures as a practical entry point. So how the current one can reduce and have less consumptions. It is something that we aim as the low-hanging fruits that we try to make it better throughout the regions. And the last one, we then also propose some data center planning that is integrated within the region. So then we can keep track on the growth. We can keep track on the facing the consequences together rather than individually as a nation. And deep within, there's also issues that we haven't touched yet, but all the demands comes from finite grid and also finite resources. So every megawatt of the hyperscale becomes megawatt that is unavailable for, say, cooling, cold chain, household, all the needs of water pumping, hospitals, and all the essentials will be faced with this that comes. And I think uh, all these issues that we're facing with the materials, with water, with land is also something that we intensively will need to face. And the last one, all the cost that comes, all the cost that will hit the grid, it is something that comes that will be shared by everyone, but then the benefits are concentrated. So not all the households, not all the entire regions will get the benefits of all this new demand growth. More of the people, more of the, previously, those that enjoying and using the demand now will only be facing the consequences without much benefits. So this is something that we try to raise and we don't have answer as of now. We try to intensify the discussions and we'll be sharing more updates in the coming months. I think that is all from our side. Thank you very much.
Thank you very much, Diandra. That's a very important picture and a very frightening number, 50 gigawatt of potential new load on the grid and on the demand side from AI or from data centers. That's a huge number, and the uncertainty definitely is not a reason for inaction. Thank you for the measures that you're from the ASEAN Centre you're thinking of recommended to the member countries. That take us to the European side of the picture on to Ana Laura presentation where she will be speaking about how the European regulatory lands have dealt with these challenges and these kind of pressures and how the EU responded to the challenge of governing fast growing and high stakes sector. Our second speaker is Ana Laura. She will be presenting EU policy drivers and the performance indicators for sustainable data centers, a topic growing internationally. And Danfoss Climate Solution have been working on this. Thank you, Ana Laura, for joining us. And the floor is yours.
Thank you, Suhir, and thank you, Yudiandra, for opening this very relevant webinar. And hello, everyone who is joining this webinar today. So my name is Ana Laura. I work in Danfoss Climate Solutions. So we are a global company providing solutions and technologies for the development of sustainable data centers. And my presentation today will be focusing on the EU approach to the topic of strengthening the sustainability of the data center sector. And I hope this can be an example that can inspire also the Southeast Asian region. As we also learned from Yudiandra, knowledge sharing is very important. So for Danfoss, for us at Danfoss, sustainability is a very important. Sustainability ensures that the growth of the data center sector can happen in a way that is also in line with our decarbonization efforts, with our energy and climate targets, at a time of rising energy demand driven by AI and digitalization. So the European Union has been exactly trying to do this, to align sustainability efforts with the growth of the data center sector. And it has been working on several initiatives exactly on this, from the Energy Efficiency Directive towards what we are now expecting to be adopted this month, which is the Energy Efficiency Package that will introduce a common rating scheme for sustainable data centers in the form of a sustainability label. And very interesting, this data center energy efficiency package is expected to be released together with within a broader tech sovereignty agenda that sees the goal of tripling data center capacity in Europe by 2030. So we see how there's this willingness to bring together sustainability with the growth of the sector. So what is this policy approach that EU is adopting? And we could summarize it in three main steps. So first of all, reporting. We need to get the right data from the data centers to understand their environmental impact. So this is the first step. Then, based on the data reported, build a common rating scheme that increases transparency and sets benchmark and rewards good performance. And finally, looking more towards the future, potentially having minimum performance standards that are achievable and that raise the level of ambition, ensuring that there's continuous improvement and clear targets towards the top efficiency levels. So as I said, the first step would be the reporting. So data center operators, this is an established framework, by the way. It has been introduced in with a delegated act to the Energy Efficiency Directive in 2024. So from 2024, data center operators need to report certain data on their energy and water use. They report this to a common European database. And this data feeds into the calculation of key sustainability indicators, which are power usage effectiveness, water usage effectiveness, energy reuse factor, and renewable energy factor. And you can see that from in the first reporting cycle of 2024, only 34% of the data center actually in scope of the reporting framework did the reporting. So this highlights the need to improve to ensure that we have all the complete data set and accurate, reliable data as well. moving then to what, as I mentioned before, we are expecting to be adopted, which is the rating scheme in the form of a sustainability label. This one that you see here is a draft because it was subject of a public consultation. So industry had the opportunity to participate and provide feedback. So now we are waiting for the revision of all the feedback and then the adoption, as I said, this month of this sustainability label. And as you can see, it builds from the reporting framework. So we find the key sustainability indicator, which are in the core mandatory section. And then we have, in addition, some voluntary sustainability features that the data center may or may not be implementing. And this label, beyond increasing transparency and setting a benchmark, it really it could have an impact on the market, especially if it is connected to public procurement and national incentive schemes. And finally, the third step, which is in evaluation. So the European Union is potentially adopting minimum performance standards, and they are assessing this possibility supported by technical studies. So what you see here in this slide is what the study team that supported the European Commission last year suggested when it comes to setting common thresholds that are achievable across all European climate zones for PUE, for WE, and for REF, whereas for energy reuse, they were suggesting to have a minimum performance standard set at local level. And also, so this was from last year, but this year there's already a new dedicated study to the topic, which gives an opportunity to continue this discussion with the policymakers and provide feedback so that we all together can shape this upcoming regulation in a way that is in alignment with both what it is achievable in the market, but also in line with our sustainability and more broadly our decarbonization efforts. And also, this is just to say that member states can go beyond what the EU introduces as legislation. For example, Germany, which has already enshrined some binding PUE and ERF thresholds that, if I am correct, will already start applying from this year. And now I guess you will be very interested in this, right? What are the global trends? And what we see is that the EU is not acting in isolation. So we see that more and more countries are adopting energy reporting frameworks, which some are mandatory, some are voluntary. But that's the direction that we see. And also when it comes to minimum performance standard, also they are getting more and more attention, specifically PUE and WE. And also very important to see the interest in the heat reuse rising, as waste heat recovery really offers an opportunity to support the resilience of the local energy system, and so an opportunity to be integrated in energy systems, which was also mentioned earlier. So really good opportunity beyond a necessity with the growing data center capacity and increasing power compute, there will be more of this heat that can be indeed put at productive use instead of being wasted. And also very good to see that also in emerging economies, there's the combination of innovative business models, like as a service models and targeted financial models that can help promote efficiency, scale efficiency, energy efficiency in data centers and unlock investments. For example, public-private partnerships. This brings me to my last slide. So the conclusions. So sustainability is really becoming a must-have for resilience, competitiveness, and public acceptance. It's really becoming a precondition for growth. Also, these regulations offer an opportunity to have predictable timelines and targets towards which the sector can work, and this will of course support innovation and the uptake of energy efficient technologies. So let's say overall, improving sustainability may bring some upfront high upfront cost, but in the long term, the benefits when it comes to lowering the energy and water use, reducing the pressure on grids, and overall the societal gains are far higher. Let's say far outweigh the initial investment. So yeah, this is my last point. Thank you very much, and I hand over to you again, Suhir.
Thank you very much, Ana Laura, and thank you for this is the last updates and information on how the European Commission is dealing with this fast-growing demand and of data centers. Now we move to the other side of the equation and the picture for the engineering side and the technology and how we actually cool this infrastructure. I'm very happy to move with Professor Shao. He's the lead author of the 59th technical brief of IIR, Cooling Technology for Sustainable Data Centers, and he will give us a view on what the engineering community is developing and have been developing and what could be solution for energy efficient data centers in the future. The floor is yours, Professor Shao. You are muted, Professor Shao, maybe? If you mute your, unmute yourself. Professor Shao, can you hear us? You are muted. Your microphone is off. Let's use this time until Professor Shao comes back. We have a question for ASEAN, for the Yudiandra. Professor Shao, yes, the floor is yours. Okay, let's wait then. Yudiandra, there is a question.
Hello. Sorry.
No worries. Over. The floor is yours. Go ahead. No. Okay. Yudiandra, you are with us for the question?
Yes.
Okay, so there's a question. The ideal location for data center should be cold, a cold country, from a weather point of view, with a low CO2. Hello, Professor Shao. Just one second. We go for a question, please.
Yes.
Hello, everyone. Could you hear us?
Yes, we can hear you.
Could you hear me? Yeah, it's okay. Just now I cannot open my mute. Okay, I'm not know what's the problem. No.
Okay.
Hello, everyone. I'm sharing my slide, my presentation on the sustainable cooling technologies for data center. Oh, could I put it down? Okay. Okay. Now my presentation is about the four parts. First is the background, and the second I will introduce the principle of the data center cooling system, and also I will introduce some sustainable cooling technologies. Then draw simple conclusions. Okay. as we all know, as the increase of the AI and big data and IoT, the similar technologies, the chips technologies, especially the power of CPU, GPU, and increase very much. So the trends. So we can see I select three companies for Intel, AMD, and NVIDIA. The three companies we can see the CPU and GPUs, the power increase, especially after 2020, the power increase speed is very fast. Okay, next. Okay, and also we can see as the increased demand of the data storage and for the computability, the increase from the 10 years ago, the total amount is a little small, but after the 2020s, the increase speed is continuously increase very significantly. Then we can know the data center market keeps about continuing for the last 6 years is keep on 11.2 percentage. Okay. Not then. And also, this also results in the global data center cooling market size is also increased. The speed is about 70%. But both the increase of the data center, I can see the global carbon emissions from the data center increase amazingly at the speed. Okay, so that's why we want to introduce some new sustainable cooling technology. Otherwise, as AI and data center increase the carbon emissions will faster and faster. Now, in the second part, I will introduce the data center cooling system, the principle. Okay. This is a typical air cooling system. We divided it into three parts. Firstly, we capture the heat from the IT component, for example, the servers inside of the chips, CPU and GPU, and the power units and the related electronics. Usually, we capture the heat, and then we transport it to the cooling source. Maybe we use the we use the water, chilled water and cool water as the coolant. Then we transport the heat to release it to the ambient environment. Sometimes when the outdoor air temperature is low, we can use the free cooling mode, use the dry cooler or cooling tower to release the heat directly to the ambient air. Otherwise, when the outdoor temperature is higher than the cool water, we use the refrigerant units such as the chiller and the similar refrigerant components. That means can make the condensing, make the water a little lower than the ambient temperature. We introduce these three parts: his capturing, his transporting, and his dissipating. Similarly, in the liquid cooling system, because of the power density of the chips increase very fast. So currently, more and more data centers adopt the liquid cooling technologies. Similarly, it's also firstly we capture the heat. Usually, we use the liquid coolant and air. Then we also transport it to the outdoor units to the then use the cooling tower. Or okay, sorry. What's the problem? Sorry, what's the problem?
One second, please. I think there is an issue with the PowerPoint. I'm sorry, Professor Shao.
Yeah.
Now maybe you can
Yeah.
I don't know what's happening. One second.
Okay.
Over to you, Professor Shao. Oh no, it's moving.
Yeah.
Okay, I think.
Oh.
Okay. Let me. Okay, I will go. There is a question from Enrique. We'll take the question until we fix the PowerPoint to Ana Laura. He's asking, is the PU ranges shown in the presentation are initial figures that the EU is adopting subject to final revision, or they are just illustrative values?
Okay.
Thank you for the question. Yes, so this is what's in the draft. It was in the draft delegated text that will introduce the rating scheme. So in the annex, it's all publicly available. By the way, it was the subject of the consultation, and indeed, this was just a draft for the moment. So we are expecting the adoption of the final version. That should be indeed coming by the end of this month. I hope that answers the question. Super. Thank you, Enrique.
Thank you, Ana Laura. I think now you can see the PowerPoint.
Yeah.
Yes.
No, I can see the PowerPoint.
Okay, good.
Some page down.
Okay, we are here.
Here.
Yes.
Okay. No. Both the air cooling system and the liquid cooling system, the similar systems framework is about both consists of three sections. So we introduce the first section, how we can capture the heat from our IT components. In this part, we can see there have different heat capturing technologies. Originally we use the room level air conditioning systems, air conditioners, and then because this PUE usually is a little higher, it can range from the 1.4 to 1.65 also. Then we want to increase the efficiency and decrease the PUE. We use the roll level air conditioners. Then it results in the PUE decrease to the 1.3 to 1.45. And because then the room it appears the rear door air conditioners as the correct level cooling system, then this PUE can decrease 1.2 to 1.35. If we want to decrease PUE furthermore, the liquid cooling system is appears, and we can get the server level cooling, and the PUE can decrease to 1.15 and to 1.30. If the chip level, the PUE can decrease to the 1.05 and 1.25. That means from the capture heat capturing section, we usually want to decrease heat heat temperature difference, and also we want to enhance the heat transfer in densities, especially when the chip, the CPU and GPU's power from usually can increase from several hundred watt to 1 kilowatt, then 2 kilowatts. So we want to minimize the temperature difference, and also want to increase the heat density. It can allow that. So the next page. This is a typical the room level air conditioner. Originally, the system inside the air distribution is not very well, so we close to the hot ISO and the cold ISO. Then we can increase the air distribution efficiency, and to decrease energy consumption. Also, we can by increase air temperature to minimize the energy consumption. Then, because the room level, the fan power of the air conditioner is a little high, so the low level air conditioners which can make the air conditioner inside the row the air distribution distance is decreased, so the fan power is decreased, and the air mixture and the liquid is also decreased, so they can save some of the energy consumption for the cold. And so the next page. Because just now we have if you want to more have reach lower PUE, so the liquid cooling technologies of these centers appear. So usually we divide this into two parts. One is that means contact liquid cooling. That means the coolant will connect directly to our electronics side. The contact cooling is immersion cooling, liquid cooling, our spray or jet liquid cooling systems. They are originally, if we the current coolant, the chemical performance and electrical performance is not very well. Before that, we use the cold plate liquid cooling. That means the coolant inside the cold plate is not directly contact to the electronics, so we can just increase its thermal performance, and also we don't have much more focus on its chemical and electrical performance. This is both of these three kinds of cooling technology. We can use also single phase cooling or two phase cooling. Okay, then next page. For example, originally the first use is a single phase cold plate. They have different structures. We can not only from the publications, and also from some companies, we can they have different type of cold plate. And then if we want to increase the heat transfer coefficient and want to decrease the coolant mass flow rate, we use develop some most of the researchers develop two-phase cold plate. That means we use the phase change latent heat to transport the electrons heat to outside. So we need it's not only increase heat transfer coefficient then, and also decrease his mass flow rate that can decrease the pump power. To the next page. And also, this is for the emergent liquid cooling. We just because just now in the cold plate liquid cooling, there are usually this mixed cooling system. Only the CPU and the GPU is cooled by the cold plate, and the other component is cooled by air. So this system usually use two kind of cold source. That means one is for the liquid cooling, the temperature can be high, and also but the air cooling they need some low temperature cold source. Usually is about 20 degree or so. Currently, some the last page. But if you want to make the whole servers cooled by the liquid, we use the immersion cooling. So this is usually we use the single phase immersion cooling, and then with some companies develop some of the two-phase immersion cooling. That can divide from the single phase to the two-phase one to increase heat transfer coefficient and decrease the mass flow rate of the coolant. Okay, thank you. The next page. Besides of the cold plate cooling and immersion cooling, usually the immersion cooling it will use a large amount of the coolants, especially at the beginning, the coolants, the price is very high, and also if the whole servers immersed in the liquid, the total weight of the rack will very high. This is so. Some companies and researchers developed spray and jet liquid cooling. From the picture, we can see only a very small amount of the liquid coolant inside of the server. So this not only reduce the coolant consumption, this and also this kind of decrease the cost of this cooling system, and also this can decrease the structural flow loading. That's sorry. And also this can not only increase the cooling performance, also decrease the cost. For the contact cooling for the immersion and spray and jet liquid cooling, the coolants have many companies developed different cooling, for example, oil and carbon, the material. Also because usually for the contact cooling, we just mostly focus on this chemical performance and electrical performance that usually can make the safety, but also for usually want to use the environmental properties. So usually the thermal performance is not very high. So some researchers in the company develop some nano fluid and they want to increase this thermal performance. So that's kind of many choice of the coolant for the contact cooling. If we compare the three different liquid cooling technologies. We have from the POE and the capital conducer, and okay. And also the current the performance we use compared to four different kind of cooling system. Usually the cold plate cooling use the comparative very large ratio in the currently data centers, and also the immersion cooling, and then the jet and spray cooling also have some modifications, and also as the increase of the continuous increase of the chips power, the single phase liquid cooling will turn to the two phase liquid cooling, and also we want to increase the technologies, heat transfer heat capture technologies. Then this is second part of the heat transporting. From this, the left picture, we can see this is a typical air cooling system. We can see usually the AHU is takes about 33% of the total energy consumption of this cooling system. Then, if we combine the chilled water pump and the cooling water pump, it's combined together, it's about 34%. And also, if it is for the heat transport, and if we combine and sorry. Sorry,
Professor, yeah, we need to conclude, please, because there is, or if you have any slides that we need to move before, maybe we can.
Okay.
Yes, please, because the time is up.
The capture for the. Okay, the three process with the heat capture, heat transfer, and heat release. We in both especially for the heat release part, we want to use natural cooling and thermal storage, and the electric cooling. Furthermore, we want to increase the heat transfer, because this consumes a lot of heat, electricity, and generates a lot of heat. So we want to waste heat recovery for more efficient systems. And then, please, next page. Okay, next page. So this is a general conclusion, because the rapid increase of these centers is catch a lot of the attentions because it results in the second greenhouse gas emissions and energy consumption. To address the heat generation for the super server small power cooling system, currently researched and applied to the new data centers. If we want to develop thermal cooling solutions, it's need about not only for we develop more efficient cooling system, and also we need to find some technology and applications for the heat recovery. That's for the sustainable cooling development of the data center. That's all. Thank you very much.
Thank you very much, Professor Shao. Just a couple of minutes for your questions. We have a question from Raphael regarding the water used for data center cooling. It's not possible to use water within a closed circuit as opposed to using running potable water. Can you answer that, Professor Shao?
Okay, can you repeat where to find the question? I'm sorry.
So the question is about the water use. It's not possible to use water used within the closed circuit as opposed to using running potable water.
Because the water used for the cooling of the electronics data center usually can, because water cannot direct to the electronics directly. So we use some the coolants to replace inside of the water for the chips and servers cooling. Especially for the liquid cooling, but the water, the thermal performance is very high, and also not only is thermal conductivity and also the thermal capacity. So we use it in the to outdoor to indoor side. This also for the long distance the heat transport, and but so after usually for the liquid out inside of the CPU and the server, you use the some secondary coolant.
Thank you very much. A question to you, Diandra. It was asked in the beginning of the of the of the of the the question was about the location of data centers. ASEAN is located as a good location for future data centers regarding the environment and the CO2 emissions from the grid. What do you think about that, Yudhendra?
Yes, I typed the answers for
Yeah.
that just
Okay, good.
to be sure that it fits. But then just to quickly answer also for everyone to get this. What is stated by Bernard Philippe, I think it is correct that cool country, then you need less, despite you also actually will still need a lot for cooling, and then also low CO2 emissions in the grid or in a possible non-grid system, and both are correct. But then at the end of the day, despite more favorable conditions in that, the competitions with other needs will still then surface. So regardless whether it is in ASEAN or in other countries with more favorable conditions, if the limit of how much this will takes up the needs will still need to be addressed. So as Analo represent in her time, I think regulatory frameworks is still the key in just to make sure, aside of the technological development, just to make sure everything is implemented well and address all the issues with limits and how this will compete with other needs. Thank you.
Thank you very much. A question to Ana Laura regarding Danfoss. One of the attendees is curious about the role of Danfoss in determining the mentioned emerging EU policies.
Thank you for the question. Indeed, it is very relevant, and the European Commission offers the opportunity to provide input, right? So that is important, exactly. Taking this opportunity and providing the input, showing the technologies also that are available for efficient, sustainable data centers that are proven in the market, and which in the end these policies will support. So in scaling. So yeah, this
Thank you.
be my answer.
Thank you very much, Ana Laura. The final question to Professor Shao regarding the fluids used. What are the most advanced alternative fluids right now? You have mentioned traditional and advanced. What about natural fluid?
Yeah, usually the water is the most best natural fluid. So this is used, and also for the secondary, that is in the electronics and the servers cooling. Currently, because the water is difficult to use, and also usually we also want to find some natural reference that can replace to get some new choice for the selection of the coolant of the center. There's many companies have developed make a lot of research on its thermal performance and chemical performance and the electrical performance properties. Okay.
Thank you very much.
There are some.
Another final question to you. In your opinion, would the data center become totally liquid cooled, or a portion of air cooling components will be reserved?
Okay, because if the anyway, I think it's not totally will turned into the liquid cooling, but most of the high density community data center will maybe use liquid cooling, but many of the data centers also use mainly for the data storage and also the chips power is only 100 and 200 watts, so this heat density is not very high. So the air cooling is still economic and efficient choice for the future data centers. As it depends on different kind of data centers use the liquid cooling or air cooling.
Thank you very much, Professor Shao. Thank you to the speakers, Ana Laura, you, Deandra. Thank you very much to ASEAN ACE Center for Energy for this partnership. I hope you enjoyed. We are sorry for the technical issue happened, but I think it moved smoothly. Thank you for the great content. Looking forward for future collaborations and see you all soon. Thank you very much. Have a great evening or day, depends on where you are.
Thank you very
Thank you,
much.
Okay,
everyone.
thank you everyone.
Bye.
Thank you. Bye.
Thank you, everyone. Have a good day, everyone. Bye-bye.